And hi guys, welcome back to our channel. I am happy and a little bit sad to say that this is our last lesson of chapter 5. Lesson 4, chapter 4, set 1. We do still have set 2 and set 3. Let me read you this. The triangle inequality theorem, because they did give us a new theorem. Theorem 15, the triangle inequality theorem. Let me read it to you guys. That is why it's the title of this lesson. The sum of any two sides of a triangle is greater than the third side. They also gave simoon, as in like halves, as in quarters. Let me show you. And then they gave some triangles, which I'll also show you. So the moon picture is right here. This is the triangle inequality theorem. And those are all the triangles that help represent it. And then this is the given and proof and the reasons why, which I'm assuming that we'll use for our next lesson in set 2 or set 3. So let's get on with it. So in these exercises, we had donkey sense, Sun, Earth, and Venus, spotter problem, SAT problem, as SAT problem, distance and collinearity, and the third side. Those were all of our sets. A lot, right? Let me read you donkey sense first. So this is their statement. Soon after the Elements was written, some people made fun of the triangle inequality theorem, saying that it is too obvious to a donkey even and needs no proof. They pointed out that if a hungry donkey were at one corner of a triangle and some hay were put on the other corner, the donkey would walk along the two sides between them rather than along the other two sides. And for number 2, they had 5 questions in this little exercise set. Let me read you number 2, and then I'll tell you my answer for it. It says, use it to write the inequality relating the sides of triangle DPH that the donkey knows. And for my answer, I put DP plus PH eating to the left side, and no matter what, it's on the left side, and DH. And that was a donkey sense, and I rated you one question because that, to me, was like a pretty important question to me, and I really like that because it really did make sense putting it in the way of someone that doesn't really know geometry, and it helps a lot. This one was the best, I think, the best set to me. It's called Sun, Earth, and Venus. Let me read you their statement. It says, the Sun, Earth, and Venus usually determine a triangle, but sometimes they do not. Now, I'm also going to show you these two of this section. This was the donkey, and this is the hay, and that's a triangle colored in green. This is the Sun with the red dot, Venus right here, and then Earth on that side. Perfect. Now, I'm going to read you I'm going to read you this other statement. It helps solve for the next 3 problems. And also I'm skipping number 6 because this part is more important. The average distance from the Sun to Earth is 93 million miles, The average distance from the Sun to Venus is 67 million miles. Tell whether or not each of the following situations is possible. In the cases that are possible, find the distance between Earth and Venus. For number 7, it says the Sun is between Earth and Venus. And I put yes, 160 million miles. 93 plus 67 equals 163. And for 8, I put, because they asked, Venus is between Earth and the Sun. And I said, yes, 26 million miles. Period. 93 minus 67 equals 26. And then for 9, it says Earth is between Venus and the Sun. And I put not possible because as in the diagram, it is not possible. We have our next one. It is spotter problem. Let me read you their statement. In the puzzle of the surfer and the spotter, in the introduction to this book, the spotter wanted to go to the corners of the island to look for ships. And then in parentheses it says, recall that the island is in the shape of an equilateral triangle with sides 20 kilometers long. And let me show you the diagram right there. So that is the equilateral triangle. Those are the sides. That is the spider trying to look in each corner for ships. For number 13, let me read you my answer because I call this question and answer because they're asking us a question and then they fill the thing that we need to fill in with a question mark. That's why I call it question and answer. So 13, they are asking PA plus PB plus PC left, and then I put 18 in the question mark. Let me read you the SAT problem. Their statements, they have two statements actually. Okay, that's not really a statement, but the following problem appeared on a SAT test, as in the SAT before you go take to college. It said the real statement, even though that actually was a statement, says if x is an integer and 2 right, x right 7, comma, how many different triangles are there with sides of lengths 2, 7, and x? And they put for number 15 as a question, could x equals 3? And it's could x equals 3 and question mark. Explain why or why not. And I put no, period. The sides of the triangle cannot be 2, 7, and 3, because 2 plus 3, then right 7. And I'm gonna go on to distance and collinearity. And their statement is, in proving our first theorem, the betweenness of points theorem, we showed that if ABC, then AB plus C, or AB plus BC equals AC. They gave us this little example with the line ABC, then they put ABC and then question marks instead of like a line. And it says next, we can now prove that if AB plus BC, then AB and C must be collinear. And they gave us that, what I just showed you. And actually, I didn't mean question marks, I meant points. And let me read you the answer of 17, which is the first one. And their question is, suppose question mark, if A, B, and C are not collinear, connect them to form a triangle ABC. And I said AB and C are not collinear. They are not collinear, guys. And let me read you what collinear and it was in our first lesson, so I hope you remember it. It's right here. Let me read you collinear points and non-collinear points because that is important. Points are collinear if there is a single line that contains all of them. Points are non-collinear if no single line contains them all. There was no line, not collinear. Okay, our last little set, or exercise, whatever you want to call it. The third side. The lengths of two sides of an isosceles triangle are 4 and 9. And they did this, let me read you the other 3 statements because they had 3 statements for a right triangle, a scalene triangle, but they were not all the same numbers. For the scalene triangle, they put the lengths of two sides of a scalene triangle are 5 and 7, and the lengths of two sides of a right triangle are 6 and 8. I'll read you my first one, and then we'll close it up. So number 21, which is the first one of the set, they asked, is it possible to tell the length of the third side? Because they asked the lengths of the two sides of an isosceles triangle are 4 and 9. And don't forget, they put explain. And I put yes, period, because the triangle is isosceles. The length of the third side must be either 4 or 9. It can't be 4, because 4 plus 4 write 9 semicolon. So it must be 9. So guys, I really hope you enjoyed that video. Yes, we did go a little bit over time, and I really hope you enjoyed the triangle inequality theorem of lesson 4, chapter 5, set 1. I hope you guys enjoyed this video. Now, excuse me and bye. I'll see you in the next one. Most likely it will be set 2, lesson 4, chapter 5. And I hope you guys watch this video so you guys can see the next one and do really well in it. Bye!